Hey, ladies and gentlemen, we're going to do Unit 9, Note 7 today. It's our last unit, our last notes in the unit. And so what this means is tomorrow you're going to work on the review sheet, and then our test for this is upcoming, and then it's the final. So we are at the end of the unit, or the algebra content. Okay, so today we're going to do synthetic division with polynomials. We looked at this type of a problem and did long division in the last section. But today we're going to do this with synthetic division. So I'm just going to jump in and show you how to do this with synthetic division right here. So our format, our little setup is a little bit different. We have this little box thing here, and we put the opposite of the constant of the divisor in there. So what that means is you look at here, I have x minus 2. Instead of a negative 2, I'm going to put a positive 2 in. And then we're going to write all the coefficients of the dividend on the top. So 5, negative 13, 10, and negative 8. I'm going to leave a blank line underneath, and then I'm going to draw a line. I'm going to put a little kickstand there. All right, so this is the basic setup for all synthetic division problems. So what I'm going to do is the first step is always to bring it down the first term. Now you'll notice I haven't thrown any of my variables in here. We don't do that until the very end. So once you have your number brought down, any number you write down here, you're going to multiply by the number in the box. So 5 times 2 gives us a 10. And now we're going to add negative 13 plus 10, and we get negative 3. So it's a number we wrote on the bottom, so we're going to times it by the 2 in the box. Negative 3 times 2 is going to give us a negative 6. And 10 plus negative 6 gives us 4. And 4 times 2, we have 8. And negative 8 plus 8 is 0. Now you might be wondering, well, what's this little like extra space there for, the little kickstand? That's where the remainder goes. So if we get a 0 in there, we have no remainder. So this problem doesn't have a remainder. And so now we're going to write this back into our form with our variables. So we look at our first term, and we're going to go 1 power less. So it was an x cubed, so I'm going to now say 5x squared. That 5 came from here. Now I have my minus 3x. I'm just going down in powers, and it's a plus 4. And then this is my solution. So if I did this with long division, I'm going to get that exact same solution. Okay, so I want you to draw a line now in this box, and these things to consider right here, I want you to write up there. So go ahead and pause the video here so you can write that up there. Okay, did you guys pause it and get that written? I hope so. All right, let's go ahead and jump here into our first two problems. So these ones are both pretty short and sweet. They only have an x squared power as the highest power. So let's remind ourselves, in the box, we do the opposite of the coefficient in the divisor. So negative 3. There's actually a 1 there, so we're going to go 1, 5, and 6. Leave a line of space, and then draw your line with your kickstand. So we're going to bring down our first term. We times that by the number in the box, so 1 times negative 3. We get a negative 3. Now we add anything here. So 5 plus negative 3, we get 2. 2 times the negative 3 in the box gives us a negative 6. So again, we end up without a remainder for this one. So we start pretty basic. Now if we look, we started with an x squared term. So now when I plug my variables back in, I'm going to go right to x. Now I can say x or 1x. Both are acceptable. Plus 2. So a short and sweet solution for that one. Go ahead, I want you to pause the video here, and I want you guys to all try problem 2. Great, how did you guys do? Did you remember to put negative 5 in the box? That's typically a very common mistake, is to forget that piece. All right, let's go ahead and jump to 3. So in the first 3 problems we've done, we have not had a remainder. So we're going to see that occur here in this problem. So inside the box is going to go opposite of the constant in the divisor. So we get positive 3. and then we have a 1, a 4, and a negative 22. I draw my line with my kickstand. All right, bring down the 1. 1 times 3 gives us 3. 4 plus 3 gives us 7. 7 times 3 gives us 21. Negative 22 plus 21 gives us a negative 1. Here is our first remainder. All right, so we still continue with 1 less power. Now we're going to do our remainder just like we did for long division, and you wrote that in your things to remember. So negative 1, and then you put it over your divisor, x minus 3. So really, we don't do too much different for that one. Hopefully you're finding synthetic division to be a little shorter and a little cleaner than our long division. All right, I want you to go ahead and pause here then and try the next problem. All right, short and sweet with that one again. So let's go ahead and jump to the back side now. Now we're going to see ones that are a little bit longer. Here we're starting with a cubed power. So in our box, we're going to put a negative 3. Our coefficients are 2, 3, negative 4, and a positive 15. Don't forget that negative in front of the 4. That's probably the most common mistake I see with this one. Bring down your 2. 2 times the negative 3 gives us a negative 6. 3 times negative, or 3 plus negative 6 is a negative 3. Negative 3 times negative 3 is a positive 9. Negative 4 plus 9 gives us 5. And 5 times negative 3 gives us a negative 15. 15 minus 15 is 0. So we go 1 power down, 2x squared minus 3x plus 5. No remainder here. Okay, I want you to go ahead and pause and do the problem 6, but first I want to let you know right off the bat that your remainder is going to be negative 121 for this. All right, so pause the video, give it a try, knowing that your remainder is going to be negative 121. All right, take a look there. Here, common things that students may struggle with this one is making sure you're taking your negative 8 times negative 4 and getting a positive 32. Okay, and that's probably the biggest mistake I see with that one. So 7 and 8 are just ever so slightly different. Of course, we can't leave them nice. If we look here at problem 7, it goes 6x to the 4th, 15x to the 3rd, negative 28x minus 6. So we're missing that x squared term in there. Now, do you remember from your 9.6 notes, the second video I did, we talked about what we need to do if we're missing that term. And we're going to put in a placeholder, a 0 placeholder. So we have our negative 2, remember opposite of the divisor. So a 6, 15, oh, here we're going to put in our 0, negative 28, and a minus 6. Draw my line, drop my kickstand. All right, so I'm going to bring down my 6. 6 times negative 2 gives me a negative 12. 15 minus 12 gives us 3. 3 times negative 2, we get a negative 6. 0 plus negative 6 turns into a negative 6. Negative 6 times negative 2, we get positive 12. Negative 28 plus 12 gives us negative 16. Negative 16 times the negative 2 gives us a positive 32. And negative 6 plus 32, we end up with a negative 24. Okay, so we have a remainder. That's totally fine. So we still go 1 power less from where we started. So 6x to the 3rd plus 3x squared minus 6x minus 16. And then this is a negative 24. You can do minus 24 over, or you can make it a plus negative 24 over x plus 2. Both of those are equivalent. All right, so I want you to pause the video here and try problem 8. Problem 8 is going to have a huge remainder. It's going to be 487, you guys. All right, so pause it here. Get that remainder of 487. All right, how'd you guys do? It was kind of a beast of a problem, wasn't it? Can you imagine doing this one in long division? Gross. All right, so 2x to the fourth plus 6x to the third plus 17x squared plus 54x plus 160 plus 487 over x minus 3. All right, let's go ahead and jump into some word problems. All right, so I'm only going to make us do 9 and we'll set up 10, but I won't make us do 10 all the way through. Deal? Deal. All right, so the area of a rectangle is x cubed plus 3x squared plus 4x plus 1 square inches. The width of the rectangle is x plus 1. What is the length of the rectangle? All right, so we got to think about, well, what is area formula for a rectangle? Area formula for rectangle is length times width. All right, so instead, and that equals the area. So instead of width, we're going to put in x plus 1. So length times x plus 1 is equal to area. Now instead of area, we're going to put in the area that they give us. X cubed plus 3x squared plus 4x plus 1. All right, we need to find what's the length of the rectangle. So we need to get L by itself. So we're not going to distribute it in. That might be some of your gut instinct when you see something in front of the parenthesis, but we don't want to distribute in. We're actually going to divide by x plus 1 because it's length times the width. So we're going to divide by the width. And if we do it to one side, we do it to the other side. Now this will cancel. And this part here is just like what we've been looking at all the rest of the problems today. So let's go ahead and do that with synthetic division. -1 in the box. We have 1, 3, 4, and 1. The nice thing about synthetic division is it doesn't really take up that much space to do it. All right, drop down your 1. 1 times -1, we get a -1. 3 plus -1 is a 2. 2 times -1 is -2. So 4 plus -2 gives us 2. 2 times -1 gives us a -2, and we have a remainder of -1. So my solution then is going to be x squared, because we went down 1 power, plus 2x plus 2 minus 1 over x plus 1. So that is the length of the rectangle. Okay, so the reason I want to set up 10 is because here it's very similar, but we're talking about triangle. Okay, the area of a triangular sail is 16x to the fourth minus 60x to the third minus 28x squared plus 56x minus 32 square meters. Whew. The height of the sail is x minus 4 meters. What's the length of the base of the sail? Okay, area formula triangle. We can either say 1/2 base times height is equal to area, or we can say base times height divided by 2 is equal to area. And I'm just going to pick this second one. It doesn't matter. They're both the same. So we are looking for the base. They give us that the height is x minus 4. Divide it by 2 and is equal to the area. 16x to the fourth minus 60x to the third minus 28x squared, whoop, plus 56x minus 32. That's a long one. All right, so we need to get rid of that divide by 2 on the left side. So what's the opposite of dividing by 2? Yeah, timesing by 2. So we're going to times both sides by 2. So the left side becomes b times x minus 4. And the right side, I have to multiply every term times 2. When I multiply the term times 2, the only thing that changes is the coefficients, not the exponents. Okay, this shouldn't be a squared. This should be a times 2. All right, 32x to the fourth, and I might have to actually slide this down here. Otherwise, I'm going to run out of space. Minus 120x to the third minus 56x squared plus 102x minus 64. Now we're set up just like our previous problem with the rectangle. To get my base by itself, I'm going to take x, or divide by x minus 4. Okay, so this will cancel, and now we have a problem that we can do synthetic division. So that boxed part there is not the answer, it's the work that you will do. I'm not going to make us do that. We're just going to stop here and go ahead and jump into your worksheet. See you guys.